This is a demonstration of Akka's multi-region replication, and we're going to look specifically at what happens in a disaster recovery scenario and how Akka can heal from that. So in this, we are going to use an example application. It's an airplane seat reservation. So you see two browser windows here, and one is connected to AWS and another to GCP. So it's actually a multi-cloud application, not only a multi-region. Now it's under normal conditions, so the regions are connected, and we can illustrate by booking a seat for Alice. Let's pick 1A. And as you see, that shows up in the other region as well. And we can do it in the opposite direction. We can say Adam book 4B. And each seat here in the seat map is represented by an entity, instance. So 1A, when Alice reserved that, we stored an event, and that's replicated over to the other region and picked up there. And the same in the opposite direction. So we can have another passenger, Bob, that wants to sit here, and yeah, works in the same way. Cancel that. And now we're going to simulate an outage. So we kind of break the network between the two regions, so they can't communicate anymore. For that, I run a little script here that will simulate this. So now, if we try to make the same booking again for Bob, it will still work. But as you see, it doesn't show up in the other region. And let me explain. So for each entity, we have a single writer principle. So the ownership of the writer is taken on the first request of an entity. And since I already had made an attempt for Bob to reserve that seat 1B, the ownership was already in AWS. So we had that ownership there already. But if we try, let's say we have another one, Charlie, and try to reserve the same seat here, that doesn't work. After timeout, that it will fail. And the reason is that the ownership was still in the AWS region. So in GCP, we couldn't take over the ownership. Otherwise, there is an exchange protocol so that the ownership can change between regions. But that means that we have like an unavailability in this application. So we can't reserve any seats here. Unless we already had the ownership as we had for Bob. So yeah, to resume business, we decide to down the AWS region. So an operator decides to do that with the Akka CLI. So we bring down the AWS region. And now, if we try to do the same thing, we try to book seat 1B for Charlie. That's successful now, and that's because AWS has been taken out, so we don't need to have the consensus protocol involving AWS anymore, and we can book other seats here. We can continue business. Then after a while, but as you see, that of course doesn't show up in the AWS region because yeah, we have both downed it and we also have the network outage still. All right, so after a while, we restore the AWS region and we want to bring it back again. So we can restore the outage and we can bring the region back again with another Akka CLI command. After a little while, things will resolve, and you see that Charlie is booked for seat 1B in both regions. So that kind of problem with having Bob in one region and Charlie in the other was resolved. And yeah, we can continue and reserve seats in from both regions. All right, so let me explain a little bit what happens under the hood. So let's go back from the beginning. So we first had seat 1A by Alice. That was before the outage. So that change was replicated over and everything was fine. But then we had the outage, and we could still reserve seat 1B for Bob. But that couldn't be replicated over to the other region. So there is no knowledge in the GCP region yet about that reservation. Then we decide to down the AWS region, and then Charlie can also reserve seat 1B because it looks like it's free. So then we have the problem that seat 1B is reserved by both Bob and Charlie. So when we restore the outage and we bring back the region, those events will be replicated over to the other region. And they will be detected as conflicts. So both the Charlie reservation will be detected as a conflict in the AWS region, and the Bob reservation in GCP will be detected as a conflict. So that's the first step, detecting conflicts. And the way we do that is we have something called version vectors on each entity and each region. There is like a sequence number for each region. So the Bob event that increased the sequence number for that region, and the Charlie event increased the sequence number for the other region. When things heal back again, all these events emerge together, and we can see from the history of the version vectors that they don't have like a common ancestor, and thereby we can see that there was a concurrent update of this entity. So that's the detection of the conflict. The second phase is to resolve the conflict, and then we decide that the surviving region, in this case the GCP, will have the authority to resolve the conflict, and it does so by using its own event history, and thereby ignoring the seat reservation from Bob. And that decision is made and then replicated over to the other region, which will apply the same decision, and thereby we have Charlie as the winner for this seat in both places. So we are in sync again. What's really interesting here is that we have this very fine-grained conflict resolution and replication. So for each individual entity instance, we can detect and we can resolve conflicts. So for other entities that don't have any conflicts, the events will just replicate and be applied on the other side. And what's also very important is that we have the event log and we have the audit trail in the event log exactly what happened. So we can still see in the events that Bob made an attempt to reserve the seat and Charlie made an attempt, and that we had this kind of conflict with the resolution. And from this, we can make compensating actions, and we can, for example, reserve another seat for Bob, and we can send a notification to Bob about the inconvenience. So it's a pretty advanced solution for a hard problem in distributed systems. But what's really good about this is that you, as an application developer, don't have to do anything in your application to enable this. It's completely managed by Akka. The application code is an ordinary Akka event-sourced entity. So for example, we have this reserve method. Yeah, it's written in the same way as if you would build it for a single region. You have the current state, you can do some validations, you can persist events, and those events are replicated and yeah, used in the other regions to restore the same state. And the conflict resolution that's applied completely automatically and no specifics in the application code for managing that. Thanks. I hope you see how powerful this is and how it can use to build really robust applications in multi-cloud, multi-region